So when we work with conductors, there's a lot of different materials we can work with, a lot of different metals that have very different properties. And you might be thinking, which of these metals should we actually use in practice? It seems like we have to make some tough decisions. Some metals are good at interacting with water. Some materials are corrosion resistant. Some are good at conducting electricity. We can't really get the best of both worlds, can we? Well, it turns out there's a trick that we can do, which can help a lot. And it's about applying coatings. So what we can do is we can take a metal and we can coat that metal in another metal. And it turns out this can add some interesting properties to the first metal. So this is called coating. So if we take copper or some other conductor and we coat it with another metal, that can provide additional properties. And there's different ways to do this. We can take the copper and we can kind of dip it in another material, and we can electroplate. But if we do this, we can kind of get different materials that we can work with. So one very common sort of coating is tin. So if we do tinned copper, if we take a piece of copper, a long copper wire, and we kind of dip it in tin so that there's an outer sheath of tin on it, then we get the corrosion protection of tin. We can kind of take it, we can deploy it in water. It also gets easier to solder because tin is soft. So we get these benefits. But we don't have the cost of using tin, because tin has these downsides. We still have a core of copper. So it's still, flexible, bendable, cheap, because we only have a little bit of tin on the outside. Tinned copper is used all over the place. If you're using industrial Ethernet deployments, you're deploying networks inside of industrial facilities, you're going to see a lot of tinned copper. You see tinned copper also on ships, in other environments where you're supposed to water, agriculture applications. If you ever have situations where, you want the low cost of copper, but you want the benefits of tin, things that can resist water and so on, then tinned copper is a great choice for that. There's other coatings as well, though. Another common application is silver-plated copper. Silver-plated copper offers some really good conduction, because silver is really good at conducting electricity. So what we can do is we can take the copper, we coat it in silver, we get that great conduction. Silver-plated copper is also great at operating over wider temperature ranges, because silver is resistant to melting. So because of this, it's commonly used in drones and aerospace applications, situations where you might have to deal with high levels of heat and so on. Another common coating is nickel. So we can take copper, coat it in nickel, and we get nickel's great corrosion protection. And also a really interesting thing is that if you do this coating, suddenly you get amazing protection against heat. Copper melts easily, but you just do a little plating on the outside, and suddenly you get nickel-plated copper, which can withstand 750 degrees centigrade. So you get amazing heat protection. Nickel-plated copper also has some interesting properties. It can reduce high-frequency loss as well. So these are some coatings that we can use in our designs. And you might be wondering, why do these coatings work? Well, there's an interesting thing that happens when you have wires conducting electricity. And you might be thinking, if I have a wire where there's electricity going down it, well, the electricity probably just kind of goes through the wire. We're probably thinking of it in terms of, you have a pipe and water going through the pipe. But that's not really how wires work. If you have a wire and you're kind of viewing a cross-section of it, one interesting thing is most of the electricity actually flows on the surface of the wire. So electrons are going to go through the wire, but most of them go along the surface. So if you look at kind of like a delta depth into the wire, most of the electrons are on the surface. So like a 5% depth actually has 90% of the electrons. And so this is called the skin effect. If you have a conductor and electricity is going down the conductor, most of the flow of the current is on the skin of the conductor. And this is actually what makes platings really work, because if you put a plating on the outside, then most of the electrons go through the plating. So because of this, you have a situation where you have your current mainly flowing on the skin of the conductor, and this is called the skin effect. And there's physics reasons for this, why this happens. So this could be a good thing because you get the benefits of these coatings. But this could also be a bad thing because you do want to use that whole wire. The less area you have to send electricity through reduces how much current you can send through the wire. So because of that, you're making a wire bigger and bigger. You're paying the cost for a bigger and bigger wire. But the amount of electricity you can fit through is just a function of the surface area of the wire. And so that's unfortunate because that increases our costs. And so you might be thinking, well, maybe we can make hollow wires. We're wasting all that metal on the inside. Maybe we could just kind of take all that metal out and just have a wire that's hollow. Well, that's really hard to fabricate. We can't really do that. So another option that we can do is kind of, instead of building one thick wire, we can do stranding. We can kind of build a whole bunch of small wires and kind of bend them together. You might think that would help, but because then we have a whole bunch of wires with individual surface areas. That would increase the surface areas. But the problem is, when these wires touch inside the cable, their adjacent surfaces form one surface. They become internal. And so touching surface area acts like a single conductor. So that doesn't really help as much as you might think. Another option is to do something where we do stranding, but we'll coat the strands in insulators. So we'll have a cable and a whole bunch of individual strands, and we'll put a little insulation on each of those tiny individual strands and kind of pack them all together in one cable. And that works because then their surfaces don't touch. And so you get flow on each of their skins. And this is called Litz wire. And this helps a lot. And it's used in applications like these power lines you see when you go outside, long distance power lines. It's used in applications where you want to reduce your costs. So this is a good thing. And this can be a bad thing as well. Skin effect is a positive thing if you want to leverage coatings. If you want to have your wire and put a coating on it, then you can leverage this property. So if you're doing things like silver tinned copper, and so on, then you put the coating on there and most electricity goes through the coating. So you can just use a little bit of coating, just a little bit of silver, but you get so many benefits from it because most electricity goes through the skin anyway. Okay, so what I've done here is I've told you about the skin effect. And so hopefully this gives you some intuition about how wiring works and why electroplating and coating of materials work so well.